Ladies and gentlemen, please welcome your Master of Ceremonies, Ray Mota.
Hello and welcome to all the stragglers out there. I appreciate you coming. We were just talking, we're going to get AI to fill in all the spots over here. But I have to tell you, last night, for those that attended, the awards was a pretty special night. You know, the MEF did an excellent job. So from myself, I'm the CEO and founder for ACG Research. We focus on the service provider space and work a lot on architecture roadmap and doing economic business models. But enough of that, you're here to see some of the panelists. So in case you're in the wrong session, this is AI to Gen evolution, edge use case in the telco opportunity. And I'm honored actually to invite Roy Chua, who's founder and principal analyst for AvidThink. Roy, if you can come up. And by the way, Roy won the Michael Howard Award there, so congratulations there.
Thank you, Ray.
Congrats, yeah.
Appreciate it.
Yeah.
Anyway, all right, well, welcome. Thank you. I'm glad we still have a huge crowd after lunch on the third day, so really appreciate it. I can see everyone. All right, I'm glad you're all here because, again, this is we have some of the cool phrases here as well. We have AI to Gen AI, edge use cases, and then telco, which is the hottest word ever, right? Oh, kind of. Anyhow, so we'll get started, but before we get started, I'm going to invite my panelists out here. First of all, we have Irfan Ali, who is Global Head of Edge AI segment from NVIDIA. Irfan, if you want to join me on stage. Thanks, Irfan. All right, and then joining Irfan is Murali Balakrishnan, who is Director of Business Innovation from Amdocs. Murali. Welcome. So I thought with the word Gen AI, we would have double the capacity of the room, people, but it is a third day. But I think with him better, I was just joking with Irfan. I said if we just had told people, like Oprah, you get an H100, you get an H100, you get an H100, right? Everyone will be in here. It's only 40K each, thereabouts, right? Anyhow. So, but we're going to talk about Gen AI. Again, a topic you have heard nothing about the last few days, so you'd be very surprised. But anyhow, so maybe just to start and sort of lay the foundation, let's talk about there are very few companies that can claim to know Gen AI well, right? I think you work at one of these that actually. So with AI, Gen AI, and obviously NVIDIA, what can you explain for us, sort of telco folks, right? What's NVIDIA's AI strategy and how you're leading the Gen AI revolution?
Yeah. Thank you.
You personally are leading the revolution.
Me personally,
yeah, you
right.
personally. Yeah. That's what it says here, yeah.
Yeah, no, so I lead the edge segment, but yeah, so let me, it's a good question, because, but first of all, you have to understand sort of our general AI strategy overall. Sure. So we provide a complete stack of accelerated computing to address AI workloads, right? So that complete stack, as a background, includes the hardware layer, which is, you guys are all familiar, you just mentioned GPUs. We make GPUs. And we also make CPUs, and we also make data processing units, DPUs, and our networking as part of our networking capabilities. On top of that, we have our operating system for AI, or OS for AI. And then on top of that, though, we build frameworks that enable you to address a particular workload for AI. For example, computer vision. We have a framework called Metropolis that allows you to create computer vision applications using our SDKs, pre-trained models, and take advantage of the ecosystems that's building on top of the Metropolis SDKs for your use cases. So as an overall, that's the strategy. Now for Gen AI, I think it really follows that same kind of construct on how we want to approach the market. We have in generative AI specifically, you're probably familiar with what the OpenAI is doing and what Gemini is doing or Google's doing with Gemini. But you need help in deploying those, and how do you provide the right guardrails and vector databases through RAGs, et cetera. So we also aid in that construct as well. So that's sort of our overall strategy.
Excellent. It's all encompassing in some sense, right? The hardware, the software stack, and the whole ecosystem as well.
Right.
So in terms of the evolution of the actual implementations, right, more so than just the stack itself, what are you seeing, and maybe what are some of the most exciting developments in this field?
Well, I think we from a GenAI perspective, we look at there was an evolution that we talked to, right? Jensen, our CEO, articulates it in the manner of there's pioneering AI, which is where companies are actually building the foundational models and building those capabilities, right? And you can, I just mentioned a few, OpenAI, Google, and others, right? Mm-hmm. And then you have enterprise AI, which are companies that are taking advantage of those foundational models and creating agents based on them to drive productivity and capabilities within their environment. And then the last one is physical AI, where you're taking that intelligence that you built in a form and in deploying it in a form, and that form that it lives in a real world environment. Mm-hmm. An example of that could be, most people know autonomous cars.
Yes.
But think about now in the tractors, in a train, in a factory assembly line, or on a factory floor. All of those are edge systems, if you will, that we can deploy this intelligence in. But to be able to, just to expand on that, to be able to do that, you need that physical AI form to be able to perceive information through sensors. It has to also be able to, manipulate and navigate a physical environment in a 3D construct.
Right.
So for that, we have a construct that we call the 3-computer approach. So you need one compute system that you're building the AI model in, where you're training that model. It could be based on a foundational model, but you need to create that. The second thing is, once you create that intelligence or that capability or agent, you need to put it in a real world scenario, simulated environment, so that you can test whether it's going to operate the way you want. Mm. We have a platform called Omniverse that allows you to create these simulation environments where you can replicate the entire real world environment in this construct. And that's important because when you deploy these models into the physical environment, you have a level of guarantee that is going to operate at least at 90+% accuracy that you need, especially in brownfield environments where you don't have the luxury of testing over and over in those environments. It becomes very critical.
Excellent. So you've painted this sort of big picture of sort of up and down the stack, the wide breadth of applications, and especially focusing on the edge deployments, which makes sense given your focus area. So I'm going to bring it to the telcos, because a lot of folks here work in the telco industry. Who better do that than Murali and Amdocs, right? So it's a telco conference, and Amdocs is obviously, among others, very focused on the telco industry. All these technology stacks and all these capabilities that Irfan just described, how do you tie that to the telco industry specifically? Any clear examples that you've worked on, that you've seen? Yeah.
First of all, congrats about the Impact Award yesterday.
Yeah, you're not supposed to bring that up. Thanks, Murali. Yeah. We talked about this.
To your question, basically we work very closely with NVIDIA. We've integrated our solution into this full stack AI foundry model, mm-hmm. which has also got the DGX cloud stack and the NeMo framework. So pretty much work very closely with them. But from an Amdocs perspective, we've got this platform called Amaze, which is our telco taxonomy. This is infused with that kind of a knowledge base. So we're actually bringing a carrier grade kind of a large language model into the business by virtue of using what NVIDIA also brings in too. So together we are trying to create or unlock the value that the telco has otherwise got. So if you look at the economy, it's a $1.7 trillion telco business. Yeah. And there's a lot of potential that the telcos have left behind for other people who use their pipes and made money off, but it's now time for the telcos to start making money too. And I think creating an AI org from that perspective, and then also from the fact that we have got several use cases, like if you were to break down the silos from lead to order, order to activate, activate to cache, and from cache to care, pretty much the large language models encompass every aspect of that. And our own product set internally has now been infused with this GenAI capability. So our product portfolio today, which we are actually, several of our customers, we got 350 customers world over, and we are talking to them on how we can bring to bear that kind of a knowledge base for their value.
Yeah, amazing.
If I may add a point to that
Yes,
we just said.
absolutely.
So, I mentioned what we're doing with our stack, but we obviously we talked about all the capabilities we have, but we are a computing stack. Sure. We don't, even though we get close to the use cases, we don't solve the use case, right? We rely on partners like Amdocs and our entire ecosystem of partners that we have to be able to work with customers jointly to be able to solve that problem, right? So that's a key thing. That's why we're in every cloud, we're in every OEM, but partnering with partners like Amdocs allows us to be able to solve that complete problem.
Yeah, and I think that's a very sort of a important point, which is NVIDIA's success in the go-to-market is not just, I mean, obviously, you want to sell a lot of GPUs to the people training the frontier models, right? Because obviously everyone wants to get a GPU, hundreds and thousands of GPUs. But certainly in terms of the unlocking the full value of it, you do need partners, solution partners that understand the verticals to take that AI and GenAI and find use cases for it, right?
Correct.
So speaking of use cases, I know the telcos and a lot of us have sort of looked at the edge, over time, because telcos believe that our closeness to our customers, whether consumer or enterprise, and the beachfront property that we all believe as telcos that we own, right, should give us an edge, literally. so speaking of the edge, and given that is your segment, right, maybe let's talk a bit about AI and the edge, right? So let's talk about some of the use cases. What are some of the interesting use cases that you're seeing now? Sort of the early, I'm sure all the telcos are all really interested, right? Because they think that they can monetize it, and they're hoping to monetize it. So what are you seeing? What's driving those use cases, and how's AI impacting? It doesn't have to be pure GenAI. It could be AI and GenAI, obviously. Right?
Just to address this last point you just made, we talk about GenAI, and GenAI is getting a lot of spotlight, but there's a lot of use cases outside that as well, right? So the typical, DNN models and that we've been doing also still apply. GenAI in some cases may be augmenting that or working with those to be able to do that, right? I think every industry. So my role, I'm a segment lead, so I cut across all industries. But in my experience, all industries are leveraging AI to give them that competitive edge, if you will, right? And they're using different modalities of AI within it. Some are using computer vision, some are using sensor fusion, some are using XR capabilities or digital twinning to be able to do that. So some examples that are notable are probably like what we're doing with McDonald's. With their customer, order process flow. So that's, that is, and I'm trying to use examples that are germane to this audience, because that at the end, connectivity and access to either devices and systems will be key to do that because it's limited by the compute and the memory that you have available at that location. So McDonald's is a great one. The other one is like the Maricopa Department of Transportation in Arizona, where they're deploying multiple cameras across their county to be able to monitor traffic and safety for people. They're also doing things with Gatwick Airport, where they're looking at plane operations, where a plane comes in, it has to refuel, it has to embark, it has to do many, many different things. So there's AI monitoring to make sure everything is, all the I's are dotted and T's are crossed in that process. So make sure that's happening. Some of the newer ones that we just recently announced are, we have working with a partner, Hitachi Rail. They are actually deploying accelerated computing, one of our IGX platforms, inside their train to be able to take all the sensor data, vibration, vision, LiDAR, and then augment the capabilities of the train. And the most interesting one, though, I'll mention, is the SETI Institute, which is the Search for Extraterrestrial Intelligent Life. They are monitoring radios. They're doing a radio spectrometer to look at radio signals across the galaxy and universe, capturing all that data and then processing it in real time now using our platforms to search for intelligent life. They haven't found any yet, but we just made it faster for them to look for it. For those are the types of things. But for all of that, like I just mentioned, for all those use cases, because they're at the edge, those edge environments are limited by the type of processing they have, the type of memory they have. So they rely on an end-to-end, sort of experience from a use case standpoint to scale these things, so that they need not only connectivity to the devices and the systems, but they also need access to the ecosystem that's going to help them make that happen.
Yeah, and I think that's clear. I think the examples that you just talked about, in very many cases, that's a connectivity component, right? Whether it's a wide area connectivity component or a local area connectivity component, in some cases could be Wi-Fi. In some cases would be industrial Ethernet in the past, or private 5G or private 4G, 5G.
All of those apply, yeah. And they're not only at the edge, they're also near edge.
Correct.
Because they just for scale.
Yeah, that makes sense, right? So doing video surveillance, and maybe you don't have compute facilities or you don't want it there.
You don't want it there.
Near edge, you can actually do the CV, the computer vision, and the actual, computation with machine learning near edge, right? So I think that's definitely very, very useful, and I'm sure the carriers have been looking at that and thinking about it. And I think the advantage with GenAI is bringing back renewed attention to just regular AI, predictive AI, right? Your CNN, RNN models that we've used successfully in the past, but maybe we've sort of missed the importance of that, and that's really key. Now, speaking of sort of these use cases, I know that Amdocs, aside from the collaboration of you using the NVIDIA stack, right, and enterprise AI stack, or the NeMo models, or the DGX, that there are other collaborations and partnerships that you worked on with NVIDIA from the Amdocs perspective. Maybe you want to share some of that with the audience as well, Murali?
Sure. I think a couple of real-life use cases, and things were nice in science projects, but I think the real value comes in when you start showing customers value from a perspective of reducing cost, bringing about efficiencies. Now, this could be, I think the immediate one that we have on hand was a customer care scenario, where the key KPIs when you talk about customer care is amount of call handling time, resolution time, and most importantly, the net promoter scores. So using this whole model that we've created, and we also use a lot of open source tools also out there, so we can actually cater to every kind of requirement, because typically not every customer's ecosystem is similar. Even though they all provide similar services, each one's siloed up in a different way. So we need to first bring in and curate that data in such a format that we can start seeing what kind of differences are there. We can do root cause analysis in the final stage of this, wherein we are trying to see how we can reduce performance management, how can we improve performance management, reduce the amount of trouble tickets that are coming in. So in a recent work that we recently, a project that we recently completed, we found that by using this technology, we were able to reduce the call handling time by 63%. And we also be able to halve the amount of resolution time to 50% and increase the NPS by about 43% on one single customer. So we think that a similar approach by other organizations too, while the usage of these learnings, I would say, because it's all about reinforced learning that you're trying unsupervised learning too at this point in time. So once we put all these things in place, it's kind of creating a kind of a reusable mechanism that you can actually take and use elsewhere. Yes, you may have to tweak it to other people's requirements, but that's one. And then the network side, you're looking at how we can take the scenario of an order to activate kind of scenario and reduce the amount of time that it takes. Today, customers take X amount of time to activate somebody, but if you were to create automation and also find ways to reduce, like for example, you bring in a lot of telemetry data. You bring in so much of telemetry data, you need the power of a GPU system to reduce and be able to provide real-time, I would say, insights for them to make decisions, and all that's possible. I think there's tremendous scope. I mean, from a Amdocs perspective, again, we do something like 1.7 billion digital business journeys on a daily basis. And if you look at that kind of knowledge base that we bring to the table, it's easy for us to figure out what would be the best way to provide the best practices that we can extrapolate to everybody out there.
Interesting. No, that's actually quite impressive. I think improving your NPS scores by 43%, right? That's everyone wants to do that. Right?
Exactly.
So they should call you.
Oh, sure.
And NVIDIA. Yeah. Get a free H100.
Call them first.
Yeah. Call them first, not you. Right. That's right. That's right. Because they are the ones that take you to market, right?
That's right.
So, excellent. Very good. I think in terms of some of these use cases, I want to bring it back to a little bit around the edge as well, right? So we talk about the edge. I guess, as I said, telcos have some level of presence at the edge. I'm always curious though, which is a lot of the Gen AI use cases. I know sometimes people are like, oh, Gen AI, we'll put Gen AI at the edge, inferencing at the edge. But then the reality is a lot of the Gen AI use cases today don't really need that latency reduction or that low latency at the edge, right? I mean, again, how fast can you type, against ChatGPT? How fast do you need that cat video, right? I mean, obviously you always want it faster. You want your video to be generated faster. More cats, better. But fundamentally, it's not clear to me that you need that extra reduction of 20 millisecond or 10 millisecond. Makes not enough difference. So when sort of the telco CXOs, and there are some CXOs here, and you have other CXOs there that say, we're going to use edge inferencing. But yet I'm sitting there and like, it's not clear to me that we need that right now. But what do you, maybe both of you seeing around edge inferencing? And is it, maybe it's not just always Gen AI, maybe it's other kind of inferencing, when we talk about that. So maybe we start with Irfan, and Murali, feel free to add in.
So I would say that it's really use case dependent. It's not always Gen AI. Gen AI, in fact, is still, right now is predominantly in the cloud and data center environments today. But there is, we are seeing that there are more and more foundation model builders that are building, medium-sized large language models, small large language models as well, that can be potentially deployed. But the question is, why are you deploying those? Now, it's not a need, it may not be a need from a latency situation. In some cases, when you're doing visual inspection for manufacturing environment, you absolutely need it there, right?
Absolutely.
If you're doing
safety,
for safety. If you're in a retail store and you're doing theft prevention, you need it on-prem, right? Or near-prem. As long as you're, there's some rules of thumb, right? 10 milliseconds or less, that type of thing. But that's not generally the need. The other main reasons why people are thinking of deploying near or at the edge is for data sovereignty. You want to have autonomous operations in a geography because you don't want to be reliant on that to be connected to the rest of the network. Potentially, you may have we know this from the energy sectors that sometimes you have an asset. It could be a solar farm or a wind farm that you want to have it completely autonomously running because eventually you may maintain that asset or sell that asset. So then you can actually sell it as a whole versus if it's tied to your entire cloud and remote infrastructure is not as easily movable. So there's many reasons why we have seen and on the reasons why you would deploy the edge or near edge versus the cloud.
I think that helps clarify it, right? Which is then at least when we talk about edge inferencing as telcos, we want to be clear about the use, as you say, the task, the use cases, whether that reduction in latency is required or whether you need, compute closer to your use case or your source of data for sovereignty reasons, right? Maybe your regional cloud is in another country and that's not appropriate, for instance, right? Murali, anything to add on that?
Yeah, if I were to speak, I'd have a fair amount of understanding how the cable business is working today. So you were to see how cable in the past, a lot of it was in the head end, it was all centralized. But now they're moving a lot of that intelligence to the edge. So it's a kind of a distributed access architecture that they're coming up with. And I think with all that, intelligence moving to the edge, you would have that much amount of telemetry coming back. And I think from that perspective, in order for the call centers or the technicians to be able to make decisions on the event of an outage, how quickly can you, handle this? I mean, it's all going to be agent-driven. We're seeing AI coming in from the network side, from an agent-centric standpoint or agentic standpoint, whatever the buzzword is for that today. It's like, so we're trying to see how we can create those agent-driven models and help the edge data that's coming in. And for that, from that perspective, latency is kind of critical, I would say. It can be near real time, but it's not real.
It doesn't have to be true real time, but near real time.
Because you need that much amount of power. You don't really need that kind of power, but if you can make do with what's coming in and if you can get that information or extract that information out, I think that'll really help do root cause analysis.
No, I think that definitely makes sense. And I think, in terms of some of the new workloads, like, to the extent that you end up using accelerated computing for RAN functions and Open RAN, then in some situations, then you will want, if you're running some of your L1 processing or your DUs, as separate from your RUs, or you're trying to use GPUs for some of that processing, then you will find.
If you're creating a digital twin,
or whatever it is, right? Then you want it closer. So I think that absolutely makes sense, and I think that's helpful. I think again, it comes down to being very specific and clear about what the use cases are and why it is, right? Because otherwise, as telcos, you want to be specific. We don't want to be sort of painting very large visions that we can't execute on and have no strong sort of real reason why.
Exactly.
Right? And I think
And
that's
the why also varies by industry that you're
yes,
that telco's
absolutely.
operating.
No, absolutely, agreed. So as we wrap up here, I mean, I think it'd be interesting. I mean, obviously, both of you are deep in the GenAI thing, and everyone wants to know what's happening, or predictions. It's always a big thing, right? Predictions, right? And if you get this right next year, we'll award you a GPU, right? I don't know what GPU by next year, right? You know, maybe the Grace Blackwell 200s at that point, right? Whatever you like next year. Someone will buy MEF, not me. It's only. But let's start with Murali and end with Irfan, which is like, so what's your predictions for GenAI in the next 12 to 18 months? What should we expect to see, right? And it can be telco specific or not. I'll leave it open, right, to you. What do you expect to see in the evolution of GenAI over the next 12 to 18 months?
I think it will accelerate a lot of the activity from a network intelligence perspective. Primarily, we think that it's going to be more intent-driven. The routing will become more intent-driven. So it'll become an autonomous network. I mean, even if you break down the network into different silos, I mean, if you say that the first level is basically, you know, it's going to be manual. The second one is a 50-50, the third one is 75-25, and the last is fully autonomous. I think what AI would eventually lead to would be to that final frontier, which would be able to create a self-healing, self-monitoring, self-running kind of networks. And I think that's where the OpEx model would really come to play, and I think AI would be centric for that kind of a transformation to happen, so that telcos and other digital service providers can start seeing real money come out of their infrastructure.
That's fair. So what I'm hearing is that TM from autonomous level 5 networks can be achieved with AI potentially. So
exactly.
Whatever the CEOs are now the CEOs at TM from were like I'm going to be level 3, level 4, level 5 by XYZ, and AI will save them essentially.
Exactly.
Yeah. Excellent. Irfan, predictions.
I think if you apply first principles to this,
yeah.
I would say that the reality is most companies and enterprises and even telco providers are maybe not going to build their own foundational models. Yeah. So I think that the lowest hanging fruit, leveraging those foundational models in your business, is going to be productivity gains, lowering costs, and then eventually it'd be looking at how can this improve my business model potentially. So I think it's going to be very much agentic. Use cases like you mentioned, something that how much can you automate or enhance your existing workers to be able to perform. So I think that's sort of what I see in the time period that you just mentioned. So then, if that's the case, then what type of skill set do you need in your environments to be able to take advantage of that? And in the past, if you're doing traditional AI, you need data prep and training skill set. Right? How do you get the right type of data, the right meta tag, so that you can train your model properly? In this agentic environment, then what are you going to need? Well, you're going to need to, how do you onboard that large language model agent that you're creating, and how do you enable them, just like you would do an intern, right. To perform certain tasks? And what is the workflow that you're going to define that these multiple agents are going to help you solve? So I think the mindset so I would say one is going to be more agentic, just like Murali mentioned, but also then what do you need on your end to be able to take advantage of that?
I think that's very fair, and I think a lot of the sort of leaders in AI are talking about agents, and Jensen himself talks about having millions of agents doing his work, right? And
that's right.
Helping his employees, right? And
well, all the GPUs that you just mentioned, a lot of them we use design agents to
correct.
design the
That's
GPUs
true.
themselves. The
exactly.
complexity is beyond what sometimes what we can manpower.
It's very meta using AI. For the meta, it's maybe the wrong word, but it's using AI to design AI, right?
That's right.
That's really interesting. But I'm glad both of you did not say AGI or super intelligence in the next 12 to 18 months. And as we wrap up here, I'm really glad that you both did not say Skynet, right? So I think we're safe for another 12 to 18 months, right? And until the new AI overlords show up, I think in the meantime we can watch all the cat videos and have a good time. All right. So with that, let's thank our panelists. Hopefully you enjoyed the conversation. We appreciate it. Thank you.